Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us see how to compute the input impedance of different length of transmission line. So here we are going to consider first 8 wavelength line, so lambda equal to L equal to lambda by 8. So in this formula, we are going to substitute beta L. There's nothing but lambda and length is lambda by 8. After cancelling, we get pi by 4. Tan pi by 4 is 1. So if you substitute tan pi by 4 1, we get Z0 into ZL plus JZ0 divided by Z0 plus JZL. And we are going to consider a resistive load RL and the characteristic impedance also resistive in nature. Okay, R naught. So in that condition, if you take the magnitude of both numerator and denominator, both will be root of RL square plus R naught square, right? Because A plus JB, for that if you take the root, it is root of A square plus B square. So after taking the magnitude and cancelling the terms, what we get R naught. 8 wavelength generally going to transform any load resistance, that is RL. Here it's represented as RR, to an impedance having its magnitude equal to the characteristic resistance of the line. Okay. So 8 wavelength line, what it is going to do, any load impedance, it is going to convert into characteristic resistance of the line. Okay, input impedance is going to be equal to the characteristic resistance. Now let us see the length of the line as quarter wavelength. Okay, lambda by 4. In that case, tan beta L becomes beta L is nothing but 2 pi by lambda into lambda by 4. That is pi by 2. Tan pi by 2 is going to be infinity, because we know that sine 90 is 1, cos 90 is 0. 1 by 0 is infinite. And substitute tan beta L is infinite directly. So we are going to consider, we are going to take tan beta L out, okay, in numerator and denominator. And after that, if you, it means 1 by infinity will become 0, these two terms. So we get Z0 into J Z0 divided by J ZL. ZL JJ get cancelled, we get Z0 square by ZL. So a quarter wave length transmission line can transform low impedance into a high impedance, similarly vice versa, and we can consider that impedance inverter. So if we have a open circuited lambda by 4 line, it is going to give zero impedance. Originally open circuited line has infinite resistance, right? But open circuited quarter wave transmission line gives zero input impedance, while short circuited quarter wave transmission line will give me infinite input impedance. So it is going to act as an impedance inverter. Now the final thing is length of the line is half wavelength, lambda by 2. In that case, beta L is going to be equal to pi, tan 180 is 0. So if we apply tan pi is 0 in both numerator and denominator, the input impedance is going to be equal to the load impedance. So half wavelength line repeated terminating impedance. So it is going to act as a one-to-one transformer. In this session, we have seen how to find the input impedance for various length of the line, starting from 8 wavelength, then quarter wavelength, finally half wavelength. Hope you understood. Thank you, everyone.